Greetings to everyone. In this video, we are going through the revision lab. If you see the tasks we are supposed to complete here, it says what? This lab serves to remind all of the concepts you learned in Introduction to Networks, in Data Networks, in Communication Networks. Okay, so the lab is going to cover a lot of concepts. Alright, so if we see this diagram, we are going to have two routers, two switches, and the two computers. The two computers are in different VLANs. So we are going to cover VLANs, we are going to cover IP addressing, we are going to configure also the routing. So if we check on this diagram, PC2 and PC1, they are in different VLANs, and according to the topology, the interface on the router is going to be their gateway. In this case, it's FA0/0, but the routers I have used, they don't have the fast Ethernet ports, so instead of FA0/0, I will be using gigabit 0/0. So let's see. Configure routers with host names. So what we can do, we can go to our packet tracer, then we can click the router. So you can see we have the config tab here, which you can use to configure the host name. But this graphical user interface, you cannot use this interface to configure many parameters. It's limited. Okay, so I would advise you to use the command line. So you click the CLI, then you type enable config t host name ISP, that is the host name for this router. The router config t host name poly. Okay, so we managed to configure these two devices with host name. So we can configure the switches also with the host names. Okay, switch 2. Okay, all right, so we managed to configure the routers and the switches with host names. We can see this table. We are given two VLANs and the network addresses. We have the network address also for the two routers. So what we are going to do for VLAN 50 and VLAN 30, I have this information already. You can revisit your subnetting and make sure you know how to derive this. If you are given this network, how can you get the valid range of IP addresses which you can use? The subnet mask is /25. So this is the subnet mask in expanded format. For VLAN 30, we have also the corresponding information for that network. So here, what we are going to do, we are going to use the first IP address from each range as the gateway. So for VLAN 50, we are going to use 192.168.2.1 as the gateway for VLAN 50 computers. For VLAN 30, we are going to use the .129. You can see the subnet mask, they are not the same. The network between the two routers is 63.10.1. Okay, so the other side we give 1, the other side is 2. Alright, so configure a loopback interface on the ISP router with this IP address. So I'll go to the ISP router, then I'll type config T, then I'll type interface loopback. So the moment you create the loopback address will be created and the interface will be up. There is no need for you to type no shutdown. So I will give it an IP address and the subnet mask. So that is fine. Verify that your interfaces are up. So what we can do here, we can assign the IP addresses already. Between the two routers, we are using this IP address 63.10.1.0. So I'll go to ISP. We are connecting to poly router using serial 0/0/0. So what I will do, I will type interface serial 0/0/0, IP address 63.10.1.1, subnet mask. I will have to issue the command no shutdown. If we check on the diagram here on the packet tracer, the connection between the two routers, on the ISP side you can see there's a clock sign. So that clock sign, it is telling us that we have to configure the clock rate on that interface. Normally the clock rate, it's used by the DCE routers to the DCE side is the one which will determine the speed at which the two routers can exchange information. So if we type clock rate here and put question mark, we can see in packet tracer we have a lot of values which we can use, but in real life you can use 64,000 or 56,000, but in packet tracer we have a lot of values which we can use because this is a simulator. So I can set the clock rate to 64,000. The interface, after we put an IP address, the clock rate, we have to use the command no shutdown. So the router interfaces, by default, they are in shutdown mode. So I'll go to the poly side, then I'll configure this interface serial 0/0/0. The IP address is 63.10.1.2. I'll issue no shutdown command. Okay, so I can test here if the poly router can see the ISP router. Yes, we can see these two routers can ping each other. Okay, so the gigabit interface on poly router, what I will do, I'll go into interface gigabit 0/0. I will not assign an IP address here. What I will do, I will type no shutdown to bring the interface up. The reason why I cannot give the IP address to the physical interface is because PC1 and PC2, they are in different VLANs, and their gateway is this interface gigabit 0/0 on a poly router, but the interface it's one, the VLANs there are two. So the only way we can solve this problem is to use what we call the sub interfaces. The ideal situation is to have each VLAN we have a cable connecting to the router, but the router, it has limited number of connections or number of physical ports. So we have to make use of one physical port and use or create many sub interfaces depending on your VLANs or on your networks. So in this case, we are going to do this interface gigabit 0/0. We put a dot. So we have VLAN 30 and VLAN 50. So when I put dot 30, this will indicate that I'm creating a sub interfaces, but this sub interface, it will rely on our physical interface gigabit 0/0. If the gigabit 0/0 is down, that means all the interfaces, all the sub interfaces associated with that physical interface will go down. So the dot 30, that will be the gateway for VLAN 30 machines. So if we go back to our table here, VLAN 30, I'm going to use the 129 as the first IP address. So I will take the first IP address from each VLAN and use it as the default gateway. So the slash is /27, which is this one. So I'm going to do this. Once I create the sub interface, you can see the prompt changes to sub IF. That means I'm configuring the sub interface. Once I create that sub interface, I have to use the command encapsulation.1q then 30. That means the traffic going through that interface will get a tag with a VLAN 30. Okay, because the traffic will be using the same link from the router to the switch, so the switch will be able to separate the traffic based on the tags assigned by the .1q method. Okay, so I'll do this, then I'll type IP address 192.168.2.129 is the first usable IP address. The subnet mask is this one, 224. Okay. All right. Then for VLAN 50, I will do the same, but for VLAN 50, the IP address we have 192.168.2.1/25. So for VLAN 50, I'll type interface gigabit 0/0.50, then encapsulation .1q50. Then I will give it an IP address 192.168.2.1 space 255.255.255.128. I think that should be the correct subnet mask. Okay, 192.168.2.1 for VLAN 50. Okay, that's correct. Then that's fine. I can type N. So if I type show IP interface brief command, we can see okay, we have the physical interface gigabit 0/0. The status is up, the protocol is up, but no IP address assigned. We created the sub interfaces and we assign IP addresses to the sub interfaces. So what you need to do on the physical interface is just to bring the physical interface up, then create your sub interfaces for each VLAN. Okay, right. So the next thing, we can see here, verify that your interfaces are up. We have seen that. Configure switches with host names. We configured already switches with host names when we were configuring the routers. Configure trunk ports on switch 1 and switch 2. So if we go to this diagram, switch 1, if you see, okay, the interface which is connecting switch 1 to poly router, it will carry multiple VLAN traffic. It will carry VLAN 30 and VLAN 50 traffic. So it's multi-VLAN traffic. So what we can do, a port which is carrying more than one VLAN, that port should be changed its mode to a trunk port. So we can type config T, we go into interface fast Ethernet FA0/1. That is the port which connects your switch 1 to poly router. Then you type switch port mode trunk. Okay, the port which connects switch 1 to switch 2, that should be also changed to trunk. So I'll type interface fast Ethernet 0/3 switch port mode trunk. Okay, I'll do the same for switch 2. So you can see switch 2 it's already complaining, blocking FA03 on VLAN 01, consistent port, inconsistent port type. So what it means, on switch 1 it's already on trunk, but on the other side is still in access mode. That's why it's complaining. So we have to type, or we have to change the port FA0/3 switch port mode trunk. So once FA03 on switch 2 is changed to trunk, the link should be restored. Okay, so if we check here, we are supposed to create, number 7, create the VLANs as follows: VLAN 30 students, VLAN 50 staff. So I can go to switch 1, switch 1, I can type exit, switch 1 VLAN 30 students. Okay, so I'll go into global configuration mode and type VLAN 30. The name of the VLAN is students. The name is case sensitive. Then I will type VLAN 50, name, staff. I will do the same on switch number 2. Go into global configuration mode, VLAN 30, name, students, VLAN 50, name, staff. Okay, so that is fine. So what you can do, the port which connects to the PCs, the port should be in access mode. If a port is in access, that means the port should be able to access one VLAN. Okay, so FA08 on switch 1 and switch 2 should be changed to access port, and we allow that port to access the correct VLAN. So we start with switch 2. If we check switch 2, that is VLAN 50 on switch 2. So I'll go to switch 2, config T, interface FA0/8. That is the connection to PC1. Then we type switch port mode access. That should be in access mode. Then we type switch port access VLAN 50. That's how you change the port to access mode, and you specify the VLAN traffic to pass through that port. Okay, so we go to switch 1, then we go into interface FA0/8, switch port mode access, switch port access VLAN 30. Okay, so if you want to, or if you try to assign a port to a VLAN and the VLAN is not yet created on the switch, the switch will be able to create that VLAN and add the port to the VLAN. But the good practice, make sure you create the VLANs first, then assign the ports to the VLANs. Do not assign a port to the VLAN, because the switch is going to create the VLAN for you. So learn how to create the VLAN yourself and assign the port to the VLAN. Okay, that should be fine. Now we can assign the PC's IP address. PC1, it's in VLAN 30. VLAN 30, we are using these IP addresses. So PC1, I can use the second IP address in the range, which is 130. So I'll go to PC1 here. So now assign 192.168.2.130 the subnet mask for VLAN 30 PC1. The subnet mask is 224/27. Okay, so I'll use 224 here. The gateway, that is the first IP address in the network, which is 192.168.2.129 for VLAN 30 machines. Okay, Then for PC2, we use 192.168.2.2. That is the second IP address for VLAN 50. The first one is 1, second one is 2. The subnet mask /25. So the /25, that is 128 at the end. The gateway, that is the first IP address, so 1. Okay, I think that's fine for now. So what we can do, we can test already. I can test if PC1 can ping its gateway 192.168.2.129. That is PC1 in VLAN 30. That is the gateway. So let's see if we are able to ping the gateway. That's fine, we are able to ping the gateway. Okay. There is one part which I skipped, I think. Okay, not yet. Verify that all the switches have the correct VLANs. So how you can check if the VLANs are created on the switch, you can type show VLAN brief. Then we can see the VLAN 1 is the default, VLAN 102 to 105, these are default VLANs. So we can see VLAN 30 and VLAN 50 are created. On switch 1, the port FA08 is associated with VLAN 30 traffic. So you can do the same, or you can type the same command on switch 2. Okay, enable access ports on switch 1 and switch 2. We have done this already. On switch 1, configure interface VLAN 30 with any unused IP address in your VLAN 30 range. So we have to create a VLAN 30 interface and assign the IP address for VLAN 30. So VLAN 30, I can use the third address 192.168.2.131. Okay, so I'll go to switch 1, type config T, interface VLAN 30, IP address 192.168.2.131 space 255.255.255.224. That is /27. Issue no shutdown. Okay. Then we have to create VLAN 50. Okay. On switch 1 again. VLAN 50. Interface VLAN 50. IP address 192.168.2.3. The third IP address is subnet mask 128. Okay, so this IP, I'm taking them from here. The first IP we used as the gateway. The second IP we assigned to the PC for VLAN 50, and the third IP, because the question is saying any unused, so I picked the third IP address. Okay, so now we have to go to the number 12, configure OSPF and EIGRP, OSPF or EIGRP. Okay, so what we are going to do, I'm going to configure OSPF. So normally what I can do, I can go to ISP and type EN, then I will type show IP route connected. So normally when you type show IP route connected, it will show you the directly connected interfaces. Those are the two networks you are supposed to advertise in your OSPF. So I will type config T router OSPF, then we put the process number, we type network 63.10.1.0 space /30. The next thing we put the wildcard mask, which is 0.0.0.3, then we specify the area 0. One network 2.0.0.0. If you are configuring OSPF, instead of entering the wildcard mask, you can enter the subnet mask directly, like this. The good thing about OSPF, it will calculate the wildcard mask for you and enter the wildcard mask in the configuration file. Okay. Alright, so we configured OSPF on the ISP router. Now we go to poly router, we type show IP route connected. So we have to advertise these three networks, this one, and this one. So what I will do, I will type config T router OSPF1 network. I will start with the 192.168.2.0 space I'm using the subnet, I'm entering the subnet mask, not the wildcard mask, because I know OSPF can calculate for me the wildcard mask. Network 192.168.2.128/27 is 255.255.224. Area 0. Last network is network 63.10.1.0 space 0.0.0.3 area 0. I entered the wildcard mask for 63.10.1.0 network. Now we can see a neighbor relationship is formed. Alright, so that is fine. I'm on the poly router now. If I type show IP route, we can see this is the loopback network, or this is the loopback IP from the ISP router. So that means ISP and poly router, they are exchanging routes. If I go to ISP and I type show IP route, I can see these routes starting with O. These two routes, they are advertised by the poly router. So the first letter in the routing table you can see from the key here, or from the codes O, it's OSPF. So that means these two routes, ISP router, learn these two routes via the OSPF routing protocol. Okay, so now I think we are fine. Now we can test if the PC can ping, PC1 can ping the loopback interface. So I'll go to PC1 and ping 2.2.2.2. Sure, we can reach the loopback interface. So I think that is the final step according to our lab. So this lab, if I can summarize, it's covering a lot of the concepts, the VLANs, the inter-VLAN routing, the trunk ports, the sub interfaces, the routing, the loopback interfaces. So all the concepts, they are covered in one lab. All right, so I hope this has been informative for you, and I would like to thank you for viewing.